Good evening, students. Let us explore about the tuning methods. Okay, so already last class we have discussed about the Ziegler-Nichols tuning method. Okay, so here let us explore about the basics and we'll see what are the tuning methods available in the using in this unit. Okay, so Ziegler-Nichols tuning method was first proposed by Ziegler and Nichols in the year 1942. So based on the experience, they have proposed a tuning rule. Okay, so here two methods we have discussed in the previous session. So here a closed loop method is a very important one where the controller remains as an active controller in the auto mode. Okay, so here how does the closed loop controller is used? Okay, so once a process reaches a steady state, so we are going to remove the integral and derivative modes and leaving only a proportional control and keep on increasing the proportional value. Okay, so here removing integral and derivative in the sense integral time is set to maximum value and derivative time to minimum value. Maximum value in the sense infinity and minimum value is 0, and on computer based simulation this can be removed completely from the controller. So select the value of proportional gain and observe the transient response. If the response decays and selects the high value of Kc, again observe the response of the system. Continue increasing the gain in a small step until we reach the sustained oscillations. So the value of gain you call that as a critical gain or ultimate gain, and the value of time we call as the ultimate period. Okay, so from these values of KCU and PU, the Ziegler-Nichols tuning methods, tuning rules are given to determine the controller settings for proportional, proportional plus integral, and proportional plus integral plus derivative. Here we are going to Here we are going to use the method called as a Cohen and Cohn. It is the name of the person who has proposed this tuning method, and hence it is called as a Cohen and Cohn. Okay, so here what we are going to do is we are going to introduce a step input of magnitude magnitude m by s to the wall. The step response is recorded at the output of the measuring. The step change to the valve is conveniently provided by the output from the controller, which is in manual mode. The response will get a process reaction curve, which is a shaped curve. Okay, so from the response we are going to compute the value of the Okay, so we are going to calculate the value of the process parameter. So here we are going to draw a tangent line, and the slope is nothing but it is bu by t, that is a slope. Okay, the magnitude is b and the respective delay time is a tt. Okay, so here we are computing the kp is nothing but bu by m. Bu is nothing but the ultimate output of the process, and m is a step input. Okay, and t is nothing but bu by s. Okay, once you compute the slope, so using a slope one can compute what is the time constant, so apparent time constant and kp. So and delay time is also can be determined. Okay, so knowing these three parameters, so one can design the controller using the controller settings proposed by the Cohen and code for different controllers like proportional, proportional plus integral, proportional plus derivative, and proportional plus integral plus derivative. Thank you, students.